This is Algebra Lesson 8-4, more multiplication properties of exponents. Now, we've already had some multiplication properties. Now we're going to add even more multiplication properties. But we're going to use properties we've already learned to find some new properties. So let's review what we already have. We've already have the following rules. A to the m times a to the n is the same thing as saying a to the m plus n. Which in other words means if we multiply two numbers that have the same base together, we can add their exponents. For example, 3 to the second times 3 to the fifth becomes 3 to the 2 plus 5, or 3 to the 7th. Any number taken to a negative exponent is the same as saying 1 over that number to the positive exponent. So 3 to the negative third is the same thing as saying 1 over 3 to the positive third. And any number other than 0 taken to the 0 power is 1. So if I have 156 to the 0 power, it is still 1. Using those properties, let's take a look at a couple of examples and see if we can figure out a pattern here. If I have 3 to the 6 and I'm going to raise that to the second power, that's the same thing as saying 3 to the 6 times 3 to the 6th. Okay, 3 to the 6th times 3 to the 6th, which is the same thing as saying 3 to the 6th plus 6, which is 3 to the 12th, because all we did was apply this rule right here. Same base, so we're going to add the exponents. Let's look at 5 to the 4th raised to the 3rd power. That becomes 5 to the 4th times 5 to the 4th times 5 to the 4th, which is 5 to the 4 plus 4 plus 4, which is 5 to the 12th power. And last but not least, 2 to the 7th raised to the 4th power. 2 to the 7th times 2 to the 7th times 2 to the 7th times 2 to the 7th, which is the same thing as saying 2 to the 7 plus 7 plus 7 plus 7, which is 2 to the 28th power. If we look closely at our powers, okay, if we look closely at our powers, we'll know this is 3 to the 12th, 5 to the 12th, 2 to the 28th. Well, if we look here, 6 times 2 is 12. 4 times 3 is 12. 7 times 4 is 12. Which leads us to another property of exponents. Raising a power to a power. If you raise a power to the power, it's the same as raising the base to the product of your exponents. So for every non-zero number a and integers m and n, a to the m raised to the nth power is the same as saying a to the m plus n. Or in people terms, if I have 5 to the 3rd and I'm going to raise that to the 5th power, that's the same as saying 5 to the 3 times 5, or 5 to the 15th power. That's essentially what we're saying with that property. Now that property helps us go a little bit further. We can use repeated multiplication to simplify an expression like 6x quantity to the 3rd power. If I have 6x quantity to the 3rd power, that's the same thing. By the way, when I say quantity, that means whatever I just spoke is in a parenthesis. That's what the term quantity means. So 6x quantity means that 6x is in a parenthesis. To the 3rd power means that everything is raised to the 3rd power. This thing is the same thing as saying 6x times 6x times 6x. If we equate what we have 6 times 6 times 6 times x to the 1 plus 1 plus 1, okay, or 6 to the 3rd x to the 3rd, which ends up to be 6 to the 3rd is 6 times 6 is 36, times 6 is 216, 216 x to the 3rd. Which leads us to our next property, because if you'll notice, if I have my entire quantity raised to the 3rd power, if I took that 6 and multiplied it, took 6 to the 3rd power and x to the 3rd power, I would have this step right here, which leads to this step right there, which leads to the property of raising a product to a power. Okay. For any non-zero number a and b and integer n, ab to the nth power is the same thing as saying a to the n times b to the n. In other words, you're distributing that exponent throughout your product. Let's look at some examples, because examples help you understand things a little bit better. If I was to take a to the 4th and raise that to the 7th power, I am taking a power to a power. So this becomes a to the 4 times 7. Or a to the 28th power. And I'm done there. a to the fourth raised to the negative 7th power, because you're going to do the same type of process, a to the 4 times negative 7. So this becomes a to the negative 28. But remember, when you're simplifying, you must change all exponents to be positive, because something's not simplified unless all exponents are positive. So this becomes 1 over a to the 28. And you have to remember all your properties, because you'll use all your properties in some of these problems. Number 3, t to the 2nd times t to the 7th raised to the negative 2nd power. And I'm going to leave t to the 2nd alone for a minute, because I'm going to take care of my power raised to a power first. So this becomes t to the 7 times negative 2. So we have t to the 2nd times t to the negative 14. Now I have a power times a power, and a power with the same base to a power. A power times a power is add the exponents. A power raised to a power is multiply the exponents. So this was a power times raised to a power, so we multiplied the exponents. This is a power times a power, so we're going to add the exponents. So this becomes 2 plus negative 14. So it becomes t to the negative 12. T to the negative 12, which becomes 1 over t to the 12th power, because you have to have it as a positive exponent. Number 4, 3x quantity to the 3rd power. Here, I'm just going to distribute my exponent throughout my entire parenthesis. So I have 3 to the 3rd, x to the 3rd, and since 3 to the 3rd is an easy number to be able to figure out the answer to, 3 times 3 is 9, times 3 is 27. This becomes 27x to the 3rd. Multiply out numbers taken to powers as long as they're less than like a million. Right? If they're a little bit more than a million, then I guess you can leave them in exponential form. 5 and 6. These are a bit more complicated. So let's take a look at these a little bit more carefully here. Number 5, I'm taking 2x to the 3rd y squared quantity to the 4th power, and I'm multiplying that by negative 3xy cubed quantity squared. I'm going to take care of each parenthesis individually, because it's a lot easier than trying to deal with the whole problem at one time. Take it step by step, and it's not so hard. So the first thing I'm going to do here is I'm going to make sure I distribute this 4 through everything within this problem. So this becomes 2 to the 4th, x to the 3 times 4, y to the 2 times 4. That's the first parenthesis. The second parenthesis, the negative is inside the parenthesis, so that means negative 3. So I have to leave it in a parenthesis again. So I have negative 3 squared, because that's the difference. There's a difference between negative 3 squared and the opposite of 3 squared. Remember, one gives you a negative and one doesn't. And then we're going to do x to the 1 times 2, y to the 3 times 2. There's my second parenthesis. Now I'm simply going to work through the problems. 2 to the 4th, 2 times 2 is 4, times 2 is 8, times 2 is 16. 16, x to the 3 plus times 4 is 12, y to the 2 times 4 is 8. There's my first parenthesis. My second parenthesis, negative 3 squared is negative 3 times negative 3, which is positive 9. X to the 1 times 2 is 2, y to the 3 times 2 is 6. Now I no longer have any powers raised to powers, but I have a power multiplied by a power. Okay, I could multiply 16 and 9, so 16 times 9 will go in one little parenthesis. Then I have x to the 12 plus 2, and y to the 8 plus 6, because a power times a power is addition of exponents. So I would multiply 16 times 9, which, if I remember correctly, is 144. This becomes 144. X to the 12 plus 2 is 14. Y to the 8 plus 6 is also 14. So we end up with 144, x to the 14th, y to the 14th. And we are done at that point. It is completely simplified. Cannot be simplified any further. Number 6 looks awfully familiar to number 5. Seems like almost the same numbers, except for you'll notice that all of a sudden, the second quantity, negative 3x, y to the 3rd, is to the negative 2nd power. Let's see what that does to our problem. Okay, so let's equate this again. This will be 2 to the 4th x to the 3 times 4, y to the 2 times 4. There's my first parenthesis. My second parenthesis will be negative 3 in parentheses to the negative second power, x to the 1 times negative 2, y to the 3 times negative 2. Now I'll just do the math. 2 to the 4th is 16, so I have 16x to the 12th, y to the 8th, and I'm going to multiply that by 9 to the, actually, I'm going to leave that as negative, because I've got a negative exponent there. I'm going to leave that as negative 3 to the negative second, x to the negative second, y to the negative 6. Okay. So that negative 3 squared to the negative second, x to the negative second, y to the negative 6. Now I'm just going to do this. I know that if I equate these, they're going to stay positive. So I'm going to have a 16. X to the 12 plus a negative 2 is x to the 10. Y to the 8 plus negative 6 is y to the second. But my negative 3 to the negative second has to move to the denominator and become negative 3 to the positive second. So this whole entire problem becomes 16x to the 10th, y to the second, all over positive 9. And that is our final answer. It can get a little hairy sometimes. So that's why you should go step by step, showing all your steps. If you skip steps, I cannot figure out what you're doing, and I'll have a hard time helping you figure out what you went wrong. Last thing, you can use the property of raising a product to a power to solve problems involving scientific notation. For example, for an expression like 3 times 10 to the 8th raised to the second power, raise both the 3 and the 10 to the 8th to the second power. So let's look at a word problem. An object has a mass of 10 to the second. An object has a mass of 10 to the second. Wow, has a mass of 10 to the second kilograms. Why that's written twice, I don't know. The expression 10 squared times 3 times 10 to the 8th all to the second power describes the amount of resting energy in joules the object contains. We're going to simplify this expression. Okay. As you can look at this part here. Extra fluff and stuff we don't need. In other words, I got too carried away typing. An object has a mass of 10 squared. The expression 10 squared times 3 times 10 to the 8th squared describes the amount of resting energy. So we're going to simplify that. So we have 10 squared times, parentheses, 3 times 10 to the 8th all squared. So the first thing we have to do is we have to take care of that scientific notation taken to the second power. So this becomes 10 squared times 3 squared times 10 to the 8th times 2. Because we're going to distribute this 2 throughout the entire scientific notation problem. So now I have 10 squared times 3 squared times 10 to the 8 times 2 is 16. So 10 squared is 100 and 3 squared is 9. Okay. Or better yet, let's just do this. Since I have the same bases here, let's equate those. I have 3 squared, which is 9, times 10 to the 2 plus 16, which is going to give me 9 times 10 to the 18th power. Okay, so the amount of resting energy is 9 times 10 to the 18th power. That's a little easier than what I was going to do. I was going to do 10 squared to make it 100, and then I was going to have to put it back in scientific notation when I was done, which is easier. As you can see, properties of exponents build on each other. So if you don't understand one property, you'll have a hard time understanding the next property that comes along.